Today we are going to discuss about ABCD parameters, which is a network parameter, and this, although is not in your course, this is useful in designing circuits, analyzing circuits. Therefore, we will discuss today the ABCD parameters. These parameters are related to networks. As you know, any network, when you say network, means in electronics we mean by network a circuit. The circuit will have some points where you can give input to the circuit. It can have some points where you can take outputs from the circuits, which means you can access the circuit through these points. These points are called the terminals of the circuit, and these access terminals at which we define the voltage and currents available in the circuit, these access terminals are called ports of the circuits. The ports and their representation of a general circuit. If there are more than one port, then we call it a multi-port network. The circuit is called a network. It is called a multi-port network if there are more than one port. Usually there will be two ports. Some circuits have one port, single port. Those are called single port network. If there are two ports, those are called two-port network. If there are three ports, those are called three-port networks. If it is four ports, those are called four-port networks. Beyond four ports, we usually call it a multi-port network. So two-port, two above, everything is a multi-port network. But usually we deal with two-port, three-port, and four-port network. Now this is an example of a one-port network. Here you can see the circuit access point is a single port where the voltage is V1, voltage across the port is V1, and the current entering to the port is I1. For example, let us take a resistor. So resistor across a voltage terminal. So there is a voltage source. From the voltage source you are taking two wires and connecting to two ends of the resistors. So the resistor gets input from one port, which is the voltage port. The whole of the resistor is the circuit, that is the network. This network is a single port network, one port network. And then consider a two-port network. This is another example. In this example, you can see two ports. In the first port, which is from the left side, we have voltage V1, current I1 entering the network. Similarly, at the second port, current V1 is across the second port. Current V2 is across the second port. Current I2 is entering the network from the second port. That also you can say that current minus I2 is leaving the network. That is how you can say. Now what can be that? What is the circuit? Look at a transistor. So if I use a BJT or a FET, so that a BJT, let us consider a BJT. So if you are considering the BJT, then the base and emitter, across the base and emitter we give the input, and across the collector and emitter you are taking the output. So base emitter from the first port, so that is port 1. Collector emitter is the second port, that is port 2 in case of a transistor. Similarly, If there are many transistors, many resistors or many capacitors, etc., then you can have an N-port network which is a multiple port. So this is an example of multiple ports. N number of ports are there. In this example, the black box shows you the network, and the input or output from the black box or to the black box are the ports of the network. To represent this multi-port network, what we use is voltage and currents. Once you use voltage and current, then you can find out across each port the impedance at the port. So we find out the Z parameter. So Z or impedance parameter. These are not easily measurable at high frequency. Z parameters are not easily measurable at high frequency because at high frequency you cannot define precisely what is the voltage and what is the current at a point. And that is principle of uncertainty. Because of principle of uncertainty, exact value of voltage and current are unknown. Similarly, admittance parameters or Y parameters, they are also not easily measurable at high frequency. Then there is something called ABCD parameter. This is the topic that we are going to discuss. This is also not easily measurable at high frequency because this is also dependent on voltage and current. Then we have scattering parameters, which you have studied in the first semester. These are measurable at high frequency. ABCD parameters we can manage to measure, although it is not easily measurable, we can manage to measure. Then, since ports are associated with network, let us have some idea on the types of network. One type of network is called a reciprocal material or reciprocal network. Based on the material, the network will be defined. If we are using reciprocal material, that is the material which has symmetric permittivity and symmetric permeability matrices. Permittivity matrix and permeability matrix are symmetric, then it is called reciprocal material. Accordingly, reciprocal device is made up of reciprocal material. Example is a biased ferrite. This is useful for making isolators and circulators that we will study later. And similarly, following this, there is something called a reciprocal network. The reciprocal network is without any non-reciprocal device or material. So if the network does not contain a device which is non-reciprocal or does not contain a material which is non-reciprocal, then the network is called reciprocal network. Now, what is the non-reciprocal device or material? Material is ferrite. Device is active device like transistors. Those are all non-reciprocal. In a reciprocal network, Zij so is equal to Zji, or Yij is equal to Yji. Z and Y matrix, they are symmetric matrix. And these are equivalent circuits for reciprocal two-port network. Let us consider what is the equivalent circuit. T equivalent circuit will be like this. If you have a two-port network, T equivalent circuit will be consisting of two impedances in series, and in between them there is a shunt impedance. The series impedance are Z11 minus Z21 and Z22 minus Z21. In between them, the shunt impedance is Z21. Similarly, pi equivalent or pi network for the two-port network is Y in series and shunting. There are two in the pi. the two legs are shunted. So the shunted legs are y11 plus y21, y22 plus y21, and the series portion is minus y21. So with this basic knowledge, let us come to the ABCD parameter. Because you have already studied S parameters, we will be discussing ABCD parameters now. Now consider a two-port network here. In this two-port network, port 1, across the port 1 the voltage is V1. Into the port 1 we are getting a current I1. Similarly, across the port 2 voltage is V2. Into the port 2 the current is I2, minus I2. It is entering, so entering is minus I2. So output from the port 2 will be I2 dash. So I2 dash is equal to minus I2. Now if we relate these voltages and currents through some parameter which are called ABCD parameter, then the relationship is like this: V1 V2 is equal to ABCD matrix. So the elements of the matrix, it is a 2 plus 2 matrix. Elements are A, B, C and D. So first row is AB, second row is CD, first column is AC, second column is VD. So that matrix into V2 I2. So V1 I1 you can get from V2 I2 by post multiplying this with the ABCD matrix. This is how you define the ABCD parameter. Then from this definition we have to find out what is A, what is B, what is C and what is D. Just look at this relationship. If we look at this relationship, then you can say easily that A is equal to V1 by V2 when I2 is equal to 0. So in this above matrix relationship, put I2 is equal to 0, then expand it. If you expand it, then you will get this V1 by V2 is equal to A, because it will be V1 is equal to A into V2 plus B into I2. I2 is equal to 0. So V1 is equal to A into V2, or A is equal to V1 by V2 when I2 is equal to 0. So when I2 is equal to 0 means port 2 is open circuited. If port 2 is open circuited, and so under the condition that port 2 is open circuited, A is equal to V1 by V2. Similarly, B will be from this relationship. Again you can find out what is B. Make V2 is equal to 0. V2 is equal to 0 means port 2 is short circuited. So B will be V1 by I2. Similarly, C, make port 2 open circuited. C will be I1 by V2. Then D, make port 2 short circuited. Then D is equal to I1 by I2. So this is how you define the ABCD parameters for a two-port network. We define these ABCD parameters. Remember that the ABCD parameters are defined only for a two-port network. We cannot define it for three-port or four-port networks. So if it is multi-port beyond two-port, then you cannot define ABCD parameters. And now let us see some examples of ABCD parameter. So consider an impedance Z. So if you consider an impedance Z and look at a two-port network which contains this parameter, this impedance Z in series, not in shunt, it is in series, then let us find out, under this condition, let us find out the ABCD parameter. So for this circuit we are going to find out the ABCD parameter. Now port 1 and port 2 in this case are open. Both port 1 and port 2 are open in this case. Since port 1 and port 2 are open, I2 is equal to 0, I1 is equal to 0. If I2 is equal to 0, I1 is equal to 0, then V2 is equal to V1. Now V2 is equal to V1, that gives us A is equal to V1 by V2. When I2 is equal to 0, we have I2 is equal to 0. So A is equal to 1. Similarly, C is equal to I1 by V2. I1 is equal to 0. Therefore, C is equal to 0. Then B is equal to port 2. When port 2 is a short circuit, V2 is equal to 0. Under that condition, I2 is equal to I1. So B is equal to V1 by I2. When V2 is equal to 0, that is V1 by I2, that is called to Z. Similarly, D will be equal to 1. So from port 1 and for port 1 we have found out port 1, port 2 is open circuit. For port 2 we have found out when V2 is equal to 0. So ABCD is equal to 1Z01. For this circuit, ABCD is equal to 1Z01. Now let us consider another example, which is a section of transmission line. Length of the transmission line is L. Characteristic impedance of the transmission line is Z0. Propagation constant in the transmission line is beta. We have two ports, port 1 and port 2. Now for this transmission line, VZ, for the transmission line, voltage at any point on this transmission line will be V plus exponential minus J beta Z plus V minus exponential J beta Z. And IZ is equal to 1 by Z0 into V plus exponential minus J beta Z minus V minus exponential J beta Z. These are from the theory of transmission line. These two expressions we know. Now at port 2, let Z is equal to 0. Small z is equal to 0, not impedance. It is the position. So reference point is at port 2. So if at port 2 Z is equal to 0, then V2 is the voltage at port 2. So V2 is equal to V plus plus V minus. From the first equation, you put Z is equal to 0 and at Z is equal to 0, voltage is V2, so left side becomes V2. That will be equal to V plus plus V minus, because exponential plus minus J beta Z is equal to exponential plus minus J beta into 0, exponential 0 is equal to 1. So based on that, V2 is equal to V plus plus V minus. Similarly, I2 is equal to 1 by Z0 into V plus minus V minus. So that is at port 2. Now, when I2 is equal to 0, if we put I2 is equal to 0, then V plus is equal to V minus, because I2 is equal to 1 by Z0, V plus minus V minus. Therefore, when we put I2 is equal to 0, then V plus is equal to V minus. Now V plus is equal to V minus, that means V2 is equal to V plus plus V minus, that is 2 times V plus. Then V1 will be equal to, V1 will be at a distance of L, Z is equal to L. So V1 is equal to V plus exponential minus J beta L. Now Z becomes L. So exponential minus J beta L plus V minus is same as V plus, therefore plus V plus exponential J beta L. Take V plus common, then it is exponential J beta L plus exponential minus J beta L, which is 2 times cos beta L. Therefore, V1 is equal to 2 times V plus cos beta L when I2 is equal to 0. So you can find out now A is equal to V1 by V2 when I2 is equal to 0. Now V1 by V2 will be, from this expression you can find out V1 by V2 is equal to 2V plus cos beta L by 2V plus. So numerator denominator V plus cancels out, leaving out cos beta L. So A is equal to cos beta L. Then we'll find out what is C. C is equal to I1 by V2 when I2 is equal to 0. I1 is equal to 1 by Z0 minus V plus exponential minus J beta L plus V plus exponential J beta L. If I take V plus common here, then this becomes V plus by Z0 into exponential J beta L minus exponential minus J beta L, which is 2J sin beta L. So I1 is equal to 2V plus by Z0 into J sin beta L. So C will be I1 by V2. So find out what will be I1 by V2. I1 by V2 will be equal to 1 by Z0 J sin beta L, because V2 is equal to V1. And so use that. And V1 is equal to 2V plus. So from that, I1 by 2V plus is equal to I1 by V2, that is equal to 1 by Z0 J sin beta L, or you can say 1 by Z0 is equal to Y0, so C is equal to J Y0 sin beta L. Now similarly, B is equal to J Z0 sin beta L, D is equal to cos beta L. So ABCD parameter for a section of transmission line with characteristics impedance Z0, length L, propagation constant, phase constant beta. ABCD are A is equal to cos beta L, B is equal to J Z0 sin beta L, C is equal to J Y0 sin beta L, D is equal to cos beta L. Now, if we take a transmission line, if we take an admittance instead of impedance, take an admittance which is shunted. Admittance, when you remember, when you consider impedances, always we consider series connections. When we consider shunt connections, we consider admittances. For impedance, we have found out ABCD parameter as 1Z01. For admittance, when it is shunted, not in series, it is in shunt, then ABCD parameter you can easily find out it to be 10Y1. Similarly, for the transformer, n:1 ratio, when the coil ratio is n:1, then for that transformer, ABCD parameters is equal to A is n, B is 0, C is 0, D is 1 by n. So n 0, 0, 1 by n for a transformer. Okay, so this is C for the transmission line. For the transmission line, C is this. This we have found out. Next. And now, suppose we have more than one network, or we have a network which contains many elements, and we can divide the network as a series connection of many other networks. That type of connection, when they are connected in series, those connections are called cascaded network or cascading. So if there is a network, there are networks which are cascaded, then how to find out the resulting ABCD parameter? Here we are taking, for simplicity, we are taking two networks. Now you can add on, follow the same principle and keep on adding other networks. Now the first network is network A, second network is network B. For this network A, at the input port, the port 1 is the input port, the voltage is VA1, the current entering it is IA1. Current leaving port 2 of on the network A is I2-A, and the voltage across port 2 is V2A. Similarly for B, the voltage entering B is V1B. Voltage across B for port 1 or input port of B is V1B. Current entering the port 1 of B is I1B. Port 2 current going out from port 2 is I1-B. Voltage across port 2 is V2B. Now if you look at this, you can see the output of network A is equal to the input of network B, which means I2-A is equal to I1B and V2A is equal to V1B. Now to the whole network, if I take it as a single network combined together, then the input is I1, the input current is I1. At the input port, the voltage is V1. Similarly, at the output port, voltage is V2. Current going out at the output port is I2 dash. Now we can say V1 I1 is equal to V1A I1A, and those two, because that is the same thing. So that you can write as V1A I1A is equal to ABCD of the parameter of the network A into ABCD parameter of network A, matrix ABCD matrix of network A into V2A I2A. That you can also write as ABCD parameter of matrix A into V1B in I1B, column matrix of V1B I1B. So V1 I1 is equal to ABCD matrix of the first network A into V1B I1B. Now V1B I1B, that is equal to ABCD parameter of the network B into V2B I2B. Therefore V1 I1 is equal to ABCD parameter of A into ABCD parameter of B. So these two matrices are multiplied into V2B I2B. Now you know what is V2B and I2B. V2B is same as V2 and I2B is same as I2. Therefore V1 I1 is equal to ABCD of AB. We'll see what is ABCD of AB. ABCD of AB is ABCD of A into ABCD of B. So ABCD of AB into V2 I2. So this is simple multiplication, matrix multiplication. If you have two networks, then simply multiply their ABCD matrix to get the resulting ABCD matrix. So this is the advantage of ABCD parameters that we use in analysis or design of microwave circuits. Because if you have two networks, you can just simply multiply them to get the resulting network. That is not possible with Z parameter or Y parameter or S parameter. This is only possible with ABCD parameter. Now once we know what is ABCD parameter and we already know what is S parameter in the last semester, let us try to have a relationship between So let us try to find out a relationship between ABCD parameters and S parameter. Assume that both the ports in this case have characteristics impedance Z0. That is the first assumption that we have to make. So port 1 and port 2, at port 1 and port 2, the characteristics impedance is Z0. and we are looking at a circuit whose ABCD parameter is ABCD. So the ABCD parameter port 1, port 2, then V1, I1, V2, I2, everything is given to us. So from this we are going to find out what is the S parameter. S11, you know by definition, S11 is V1 minus by V1 plus when V2 plus is equal to 0. That is the S11 parameter. Now you know what is V1. V1 is equal to V1 plus plus V1 minus, which is equal to A V2 plus B I2. From that you can say V1 plus plus V1 minus is equal to, if I take V2 common, then A plus B into I2 by V2. I2 by V2 is Z0, characteristic impedance Z0. So V1 plus plus V1 minus is equal to A plus B by Z0 into V2 minus. Now you don't ask me why V1 is equal to V1 plus plus V1 minus. I have already told you when we discussed it about the ABCD parameter. It's taking a section of transmission line. So the reference point is at the port 2. Under that condition, V1 is equal to V1 plus plus V1 minus. Taking the appropriately taking the reference point. Similarly, I1 is equal to 1 by Z0, V1 plus minus V2, V1 minus. That you can write as C into V2. I1 is equal to C V2 plus D I2 from the ABCD parameter. So that if I take V2 minus common in this, if I take V2 minus common, then we will get this is equal to C plus D by Z0 V2 minus. Now V2 is equal to V2 plus plus V2 minus by appropriate choice of the reference point, and minus I2 is equal to 1 by Z0 V2 plus minus V2 minus. Now let us use these values. So V1 plus plus V1 minus will be equal to A plus B by Z0 divided by C plus D by Z0 into I1. So that we can write as for I1, we can write as 1 by Z0. I1 is equal to 1 by Z0 into V1 plus minus V1 minus. So that if we multiply 1 by Z0 in the denominator, then that gives us A plus B by Z0 divided by C Z0 plus D into V1 plus minus V1 minus. So V1 plus plus V1 minus is equal to A plus B by Z0 divided by C Z0 plus D into V1 plus minus V1 minus. And now find out what is S11. S11 is equal to V1 minus by V1 plus when V2 plus is equal to 0. So that we can now write as this: A plus B by Z0 divided by C Z0 plus D minus 1 divided by A plus B by Z0 divided by C Z0 plus D plus 1. So that will be equal to A plus B by Z0 C Z0 minus D minus A plus B by Z0 minus C Z0 minus D divided by A plus B by Z0 plus C Z0 plus D. So S11 is related to ABCD parameter. Similarly, S12 you can relate, find this same way you can find out the relationship. This will be equal to 2 times AD minus BC divided by A plus B by Z0 plus C Z0 plus D. Numerator remains same. S21 will be equal to 2 times 2 by A plus B by Z0 plus C Z0 plus D. And S22 finally, S22 is equal to minus A plus B by Z0 minus C Z0 plus D by A plus B Z0 plus C Z0 plus D. So this is the relationship between ABCD parameters and S parameter. So if we know the S parameters, from that, if we know the ABCD parameter, from that we can find out the S parameter, and vice versa. Again, using the same thing, you can find out what is A, what is B, what is C, what is D in terms of S11, S22, S21 and S1. So this is basically a overlook of ABCD parameters, or the definition of ABCD parameters, some examples of ABCD parameters which are useful, and a relationship. With that, we come to the end of today's class, today's discussion. In the next class, we are going to discuss about some other parts about